I'm Sal Khan.
Just kidding!
It's Eileen Khan. Gwen Khan.
Kelly Khan.
Josh Khan.
Helena Khan.
Annika Khan.
And Darina Khan.
Okay, so we'll start off with exponent rules. So the first rule is if you have x to the power of a times x to the power of b, because it's multiplication and they're the same basis, you're going to add the exponent, so your final answer will be x to the power of a plus b. The next rule is if you have x to the power of a over x to the power of b. Again, because it's the same basis, but it's division, we're going to subtract the exponent, so your answer will be x to the power of a minus b. The next rule is if you have x to the power of a in parentheses on all of that is to the power of c, this becomes multiplication, so your answer will be x to the power of a times c. The next rule is if you have x to the power of a times y to the power of b, and all of that is to the power of c. C gets distributed, and your final answer will be x to the power of ac times y to the power of bc. Next, if you have x to the power of a over y to the power of b, and all of that is to the power of c, again, the c is distributed, and this becomes x to the power of ac over x to the power of y to the power of bc. Next, if you have x to the power of negative n, this becomes 1 over x to the power of n, and n can be distributed to create 1 to the n over x to the n, which can be simplified to 1 over x to the n. The next rule is if you have x to the power of 0, or any number to the power of 0, it is always 1. And the last rule is if you have x to the power of an exponent, such as a over b. This becomes x to the power of a underneath the radical, and the number in the insert of the radical is b.
Simplifying exponential equations. First, we have the formula for converting radicals to exponents because that's often important when simplifying exponential equations, and then we have some examples. Here, you distribute the 5. As you can see, 2 to the power of 5 is 32, and here you multiply the exponents. 3 times 5 is 15, so x to the power of 15. We follow that same pattern here. 6 squared is 36, and x to the power of 2 raised to the power of 2. You multiply those, so it's x to the power of 4. And then 36 over 12 is 3. X to the power of 4 over x to the power of 2. You subtract the exponents, so that's x squared. Here, 5 times 3 is 15, and x to the power of 2 times x to the power of negative 4. You add these exponents for x to the power of negative 2. And then this is the same subtraction pattern since it's division. And negative 4 minus negative 6 is 2, and 3 minus 2 is 1.
Today we will be learning about exponent equations. So, if b to the power of x equals b to the power of y, then x equals y. So for an example, 5 to the power of 3x equals 5 to the power of 7x minus 2. So since the bases are the same, we can cross out the 5's and we're left with 3x equals 7x minus 2. Then we just solve for x and we get x equals 2. For another example, where the bases are not the same, we have 3 to the power of x equals 9 to the power of x plus 2. We simplify them to the same bases, and then we cross out the bases because they're now the same, and then you just solve for x. And you might think to divide by 2 here, but you should not do that. Rather, you should distribute the 2, and then you're left with x equals negative 4. Thanks for watching.
Hello guys, so today we're going to be talking about graphing, and we're going to start off with exponential. So the parent function of an exponential graph is y equals b of x. The two main points we're going to need to know and always graph are 0, 1, and 1b. And we also have to make sure to always graph the asymptotes. So the two cases that we're going to learn first are when b is greater than 1 and when b is in between 0 and 1. Here are what the basic graphs are supposed to look like and where the asymptotes are in relation. So next we're going to be talking about graphing for log. So once more, the parent function is now y equals log b of x. So the 2 points are now 1, 0, and b, 1. And remember, once more, asymptotes. So the b, as you can see, is the same as in the equation. So when b is greater than 1 and when b is in between 0 and 1, here are what the functions will graph like and the asymptotes. So the characters I've listed out here and highlighted are the ones that we've mainly been doing this whole year and always have listed out. The only special one for this unit, I would say, is probably the asymptotes.
And now we'll transform these exponential functions. Over here we have the basic equation, which is a times b to the power of x minus h plus k. Where a is the dilation, b is the base, h controls the horizontal phase shift, and k controls the vertical phase shift. Here's an example of a shifted exponential equation, 2 to the power of x minus 3 plus 1. Now what I've drawn here is an unshifted version of the graph, 2 to the power of x. And now for the transformed version, which has been shifted right 3 and up 1. Because of this transformation, the point which was once on 0, 1 is now at 3, 2.
It's Helena Khan, and today we're going to be doing exponential modeling. First, we're going to take the points we're given from the word problem, and we're going to write them down, and then we're going to use the equation a times b to the x equals y. And first we're going to use the 0 point and plug 0 in for x because anything to the power of 0 is 1. So we can solve for a, and we get that a equals 1.6. So we're going to plug 1.6 back into the equation, and we're going to use the second point we have, and then we're going to use algebra to solve for b. So we're going to divide both sides by 1.6, and then after we divide both sides, we're going to take the square root of that, and then we get b equals 1.837, and now we have our equation. So we can use this equation to solve for other questions in the modeling problem.
Now we have compound interest, which is, as defined by Merriam-Webster Dictionary, the number, A, computed on the sum of an original principal, or P, and accrued interest rates. And there are 3 equations to describe this. If compounded annually, the equation is A equals P, 1 plus R to the T. If compounded multiple times in a year, the equation equals A equals P, 1 plus R over N to the NT, where N is the number of times per year. And if compounded continuously, the equation is A equals P E to the RT. Here's an example. Saul puts $3,000 into a bank account that compounds 12% interest every year. Now, since we know it's yearly, we know the equation would be A, which is the amount, equals 3,000, or P, 1 plus 0.12, which is 12%, raised to the T, where T is the number of years.
It's Eileen Khan.
Hi, I'm Sal Khan.
It's Eileen Khan. You said I don't know what. Kidding. Wait.